Good morning and welcome to all. I'm Saurav Basu and I head Realization Technologies India. Thank you for joining the webinar. It's going to take around 40 minutes for the presentation and the final 20 minutes will be for Q&A. All of you would be on mute, but you can raise your hands when you have questions and Sanjeev will take them during the webinar. Project management is a very broad topic. This seminar will be focused on delivering projects. In a large project, we make hundreds and thousands of decisions. Sanjeev will focus on how to streamline executive decision support during planning and execution of projects. Before we start, I'll quickly introduce Sanjeev. Sanjeev is the founder and CEO of Realization Technologies. Realization is an US-based company, and this is Sanjeev's second company. He sold off the first company and started Realization in 1998. Realization is a market leader in delivering projects, and over 300 customers of Realization across the world all record impressive improvement in their project delivery performances. And around 10% of them also reported bottom line improvements, totaling to more than $6 billion. Sanjeev has a bachelor's from IIT Delhi and a master's in mechanical engineering from Virginia Tech, and a second master's in management and public policy from Carnegie Mellon. He has led Realization to many prestigious awards that includes the Shingo Gold 3 times, the US Air Force Chief of Staff Team Excellence Award, and the Franz Edelman Award, which is considered the Super Bowl of operations research. In addition, Sanjeev holds 8 patents with the US Patent Office. In 2016, Sanjeev was also honored with the Lifetime Achievement Award by the Theory of Constraints International Certification Organization. With this, I will hand over the webinar to Sanjeev. Thank you, Sanjeev, for being with us today. You can now take over.
Thanks, Saurav. Thanks for the nice introduction. Hello, everyone. So we will conduct this webinar at generally a fast clip, but as Saurav said, feel free to raise your hands, ask questions during the webinar. And as Saurav mentioned, the objective of today's webinar is mostly about how to streamline decisions. So you already know how to make good decisions in projects. So we will talk a little bit about how to make better decisions, but mostly it will be about how to streamline and make the decisions that you already want to make in projects. And from a project delivery perspective, the decisions are kind of twofold. One is when the projects get into execution, if you're dealing with large complex projects, especially, whether it's building of a power plant, building a factory, or even developing a complex new product. How do you achieve predictability and control in projects? So what is the decision support that is required for achieving that predictability and control? And if you have multiple projects especially, but even in single projects, there's always the issue of resources. So how do you optimally use limited capacity? And finally, we will talk about there's been a lot of investment talk about dashboards for the last 6, 7, 8 years. But what you normally get is something that is worse than a pilot's cockpit, where you have many dials, many red, yellow, greens all around the place. And the information is just a little bit too much for executives to make quick decisions. So we will talk about what information is actually useful for delivery managers in single projects as well as multiple projects. Some basics, you already know this, but it's good to recap. By predictability, what we are talking about is how do you commit a reliable due date to your customer? And in case your projects are tied to cash flow or some other business outcomes, how do you making reliable projections of due dates is important even for making projections about those business outcomes. So this is one side of it. Control is the other side, that once you have made a commitment, now how do you meet the commitment? And what it really means from a management perspective is that on a daily basis, you are making many decisions, you're taking many actions to make course corrections. How do those decisions and actions have a reliable impact? Which means as you make decisions, as you decide to expedite some parts of the project, as you decide to spend some extra money in some part of the project, how do you make sure that whatever outcome you wanted from that expediting decision, will have the impact that you wanted. This is something that you all know, but there's just a subtle point I want to mention here. Of course, in a project, if we are looking at a single project, you build a project plan and you find out what is the critical path of the project. And that critical path of the project tells you when you can start the project and when you can finish the project or a certain milestone and achieve the business outcomes. So we all know that having understanding the critical path allows you to make a prediction. The subtle point here is that the critical path has to be reliable, right? So it cannot be that you start with a critical path and it keeps changing every day. So your critical path has to be reliable, even though the project is going to be subjected to many uncertainties along the way. One of the projects that we did with National Thermal Power Corporation is a 5-year project, which is design of a power plant through the procurement aspects all the way through commissioning. And in those 5 years, the critical path changed about 2 times, right? So that is the frequency at which you can absorb changes in the critical path. And if you don't have a reliable critical path, you can make predictions, but you will not be able to make reliable predictions. As I just mentioned, changes are going to be inevitable. There are going to be just all sorts of delays that happen. Some tasks take longer, some tasks take shorter. Then you have, as you start a project, if you have engaged with contractors and vendors, they also start submitting their schedules. They make a commitment, but then they change their schedules and submit those schedules. So that causes a change in the projects. As the projects start falling behind, you make catch-up plans. There are technical changes in the projects, which is you assumed a certain condition for geological set of geological conditions or technical conditions, but they don't materialize. So you need to do the project differently or to achieve the same outcome. Right? So shortages crop up, the scope gets modified. So all these changes that happen in the project, what it ends up meaning is either the duration of the tasks are changing, or sometimes you are changing the task. You're deleting some tasks, you are adding some tasks. Sometimes you are changing the way tasks connect to each other. You assumed task A could be done before task B, but in reality, you find that task B can be done before task A. And the sequences change. So these sequences can change in the sense that you can decide to do some part of the project before the rest of the project, and you might change that sequence when you get into execution, depending on what is happening with your resources. So the point here being that this is where control comes in. And to have good control, you need to keep the project plans current. Right? This is obvious. So that is not the main point. The point is that as you make those changes to the project plan in an effort to keep the project plans current, what ends up happening is your critical path changes. So now a different set of paths are controlling your execution. A different path is controlling what will happen to your due date. As I mentioned before, that for effective control, for you to have a reliable impact, your controlling paths cannot change every day. Right? So having reliable controlling paths is necessary for effective interventions. And when you don't have a reliable controlling path, what you observe in your organization is there is an official plan, which is the PMO plan, but senior management is working on their own intuition through their own site visits. The frontline managers are also carrying their own back pocket schedules because they cannot rely on this project plan that is changing all the time, or this controlling path that is changing all the time. And this kind of is the issue, that to achieve this predictability and control, if you have some real projects, so we're not talking about 2 or 3 week development sprints for software or websites, we're talking about real projects. So in a power plant, as I said, a 5-year project, somewhere between 20,000 to 100,000 execution tasks. Aircraft maintenance, repair and overhaul. Small CD check, about 100, 200 word cards, 500 word cards, or a long C check can take 10,000 uh, uh, tasks. Sorry, a B check could be 500 tasks, and a C and D check could be longer. Product development. Something as simple as developing a medical device. You end up with about 5,000 execution tasks in developing a small medical device. Or engineer or auto manufacturing, whether you are doing high pressure vessels or making complicated machinery. So again, you end up with a lot of tasks. And the implication of this is where decision making gets chaotic and it is no longer stays streamlined, is the effort required to keep your project plans current with changes happening in such projects is just too much. What it really means is your project plans are kind of never current. By the time you make the changes and you update your project plans, it doesn't happen overnight. It takes a week, sometimes a month to make keep those project plans current, which means by the time you have made the changes, your project plans have lost their relevance anyway. The other big impact is that when you are making changes at this level and you are changing the task, you are changing the dependencies, the likelihood that your project network is going to be stable, your critical path is going to be stable, goes down, right? So you change some dependencies, you change the task, you change the sequence in which work is done, and suddenly what you find is your critical path is changing all the time. So in the real world projects, it's impossible to keep project plans current, and is also impossible to keep the project network stable. And without a stable project network, let's say you can afford to hire a large PMO team, you can keep investing in bigger teams. Maybe, very talented people, a PMO team of 10, 20, 100 people. We had one project with an aerospace and defense company. This is development of a tanker aircraft. So there were about 5,000 engineers working on the project and 500 schedulers working on the project. But even they could not keep their project plans current. So, and moreover, even if the project plans are current, the project network is not stable. Similarly, you can invest in technology. You can say, maybe people doesn't work, but we can invest in technology and we can have real-time data collection using mobile devices, all kinds of devices, and do some automation. And maybe that will solve the problem. But the challenge again is that even with all that technology, with all that manpower, what you end up with is changes that cause your project network to become unstable. So without a stable project network, you will not have predictability and control. And this is really kind of the impossible situation that you end up with. That to keep the project plans current, you want to change the project network. But to keep the project network stable, you don't want to change the project network. Right? So anyone who disagrees or who has doubts about this aspect, that this requirement of that the project network should be kept stable if you want effective control through the life of the project. Now would be the time to raise questions or uh, uh, raise your objections. Otherwise, I will assume that you agree with what I'm saying, and I'll keep moving forward. So, how do we get out of this impossible situation? So one more implication of this impossible situation is that on the one hand, there is a need to keep changing the project plan current. On the other hand, you want some stable project plan so that you can make decisions. So what ends up happening is there is a PMO view, which is your official project plan. And this is just the minimum number. There's a management view, which is an abstraction of that project plan, down from hundreds of thousands of tasks to maybe of tens of tasks, but it's a different plan. And similarly, people on the front line, they have their own back pocket schedules that they are manipulating, changing all the time based on what they are experiencing on the ground level. This is a much more localized plan, which is a plan only for their area or only for their team. And all these plans end up being disconnected, right? Because the PMO plan is kind of never current and it's kind of never stable. So the front line creates their own bucket pocket plans that they keep updating, and the management keeps an abstraction of the plan which it thinks can be more current. And this other uh, fad that is going on, that we need to have a single source of truth, the single source of truth cannot materialize just by connecting IT-wise these different data systems. What you need really is a stable network first and foremost. If you do not have a stable network, then you will not be able to satisfy the needs of the management and the front line from the same project plan. And if you don't have real-time algorithms that can process the data as it gets collected and converts that into intelligent information with this stable network, then you will keep investing in people and technology, but your project plans will never be current. So what I'm going to talk about in the next few slides is what are the enablers? How can we get a stable network in a project that might last somewhere between 3 months to 5 years, where all kinds of changes are happening every day? How do we create a stable network? And what kind of real-time algorithms can we provide to process the data as it is updated?
Sanjeev, I think there is one question.
Yeah, go ahead. What is the question? I cannot see the question, sorry. Tell me the question. Saurabh? Saurabh, what is the question? Hello? Hey, Mohsin, can you tell
Yeah,
me what?
I can see the raised hand. I can't see the question. So it's from David Hodes.
Uh, can you open up the mic to David? Yeah, David, go ahead.
Hi, Sanjeev. Yeah, I'm just interested in your view on the difference between common cause variation on a stable platform versus a special cause. So, if you can just talk a little bit about the difference between the two, because we say stable, but stable and then something big happens like COVID or something.
Very good. So great question, right? So in a project, I think the point, David, that you are making is there is the daily death by 1,000 cuts that happens. Something is laid by a day here, a day there, and then there are these major fatal blows that happen, right? Which happen once in the lifetime of a project or twice in the lifetime of a project, right? I think that is the point you are making. If not, then let me know, right? So
that's good,
right? So the point here is that we can't do much about the fatal blows, right? So if you assumed that you are going to get clearance for land, but some political situation developed where that land clearance is just not going to happen, right? So you need to replan the project. There's no way out of it, right? So in some sense, what I'm talking about is, so instead of common cause and special cause, what I would do is I would differentiate between these day-to-day changes and disruptions that happen versus major events that happen, which can be cataclysmic. So when you have major disruptions, you need to replan the project. But so which means your critical path will change, your project network will change. But that doesn't need to happen every day. That does not need to happen every month. That needs to happen. So we did a project of building a shipyard. Okay, so in that project, what happened was, this was about a 24-month project, and there was a major delay on steel supplies. Steel supplies were needed for building the ship lift, and the supplier went bankrupt while the steel plates were on the sea. So the ship was stuck on the sea for about 6 months. So no work could have been done. So we had to replan the project. Right, but then there were other delays. For example, there was a delay, a month and a half delay in mobilizing the labor. There were some just bureaucratic delays in getting land clearances, nothing to do with political situation, just bureaucratic delays. Right? So these are 5-day, 10-day, 15-day, 30-day delays in a 2-year-long project. And those we could absorb and still have a stable project plan. So in terms of the enabler that is required to have this stability, despite these day-to-day changes that are happening, from all angles, from all sides, changes are just hitting you. You need to move the project plan up a little bit to a level where it can stay stable. So the analogy I would take is uh, Google Maps, right? So in Google Maps, it's giving you great directions, right? But it's not telling you when to change your lanes. It's not telling you when the light will turn green or red. It's not telling you when to get out for coffee, right? It's just telling you when do you need to make turns. Is at that level it is operating. So in a typical project, what we have found is, and I'll just take an example and sort of correct me if I'm wrong. And Michael is also here. Michael has great experience across a wide range of projects. So in the thermal power plant construction, from 100,000 tasks, if we go up to about 1,500 tasks, this roadmap becomes very stable. In aircraft maintenance, repair and overhaul, if we go from 3,000 work cards to about 40 to 50 tasks, and David, I think you have dealt with some of these projects too, right? The roadmap becomes suddenly very stable. The trick is, this is the trick, that you still need to have execution details captured below these, what I will call super tasks, right? So these details need to be updated, changed as frequently as the changes happen and as frequently as you can do them. But the project plan at this level stays quite stable. So this is not a project plan that is just like 2 or 3 milestones or 4 or 5 milestones or just 10 bars on a Gantt chart. Right? This is still a meaningful project plan with 1,500 tasks for the thermal power plant construction, or in a typical new product development project, about 50 to 75 tasks. Right? So this is still a meaningful project plan. And the trick is that you run your critical path or whatever algorithms you want to understand where the critical path is, where the controlling paths, you run them at this level. And any priorities you get from this, you blow them down to the lower level details. So in this case, for example, an intake well construction could be comprised of about 7,500 activities. So whatever the priority of this super task is, all those priorities flow down to the lower level details. But your critical path, critical chain, all those algorithms that you want to run for control, they are running at this level. Right? And this roadmap is an executive roadmap, because in this roadmap, you are also making decisions about what's your strategic sequence for doing the work would be, how you will organize your resources, what is your risk mitigation strategy, right? So when we talk about moving risk to the left, so is at this level, you will say, this is a risk reduction task, for example, and there will be details below this. So the entire management strategy is reflected in this roadmap. And the actual work that happens on a day-to-day basis is reflected at this level. And so this is the level at which you can keep making all the changes you want. But the beauty of that is all those changes, all they will do at the most is change the duration of these tasks. They will not change the dependencies or the network itself at this level. Once you have, and this is again, I want to just keep emphasizing, this is different from a typical project plan that you will see in Microsoft Project or Primavera. In Primavera, you can have level 1, level 2, level 3, level 4, level 5, level 6 schedules. But whatever is the lowest level of detail, that is where the critical path algorithms start running. And that just makes the entire network unstable and unwieldy. The trick is to keep running the critical path at this level. And there are just 2 levels here. There's a roadmap and there's execution details. The second enabler, a lot of you will already be familiar with it, is that, okay, so by doing this, we are able to come up with a stable roadmap, but still the fact is that my durations of these blocks, so these blocks could be somewhere between 2 weeks to 2 or 3 months long. So as you make the changes in the execution details, these tasks will expand or contract, right? So the durations of these tasks are changing. So when those durations change, still there is some room left for the critical path to change. And the solution is kind of simple, which is smart placement of buffers. So for example, in this case, if this was my critical path to begin with, okay, so I put a buffer at the end to protect the delay on the critical path, uh, to, to protect the project from the delay on the critical path. But what I also do is I put these feeding buffers in so that any delay on the non-critical path does not propagate to the critical path. And so this is what the second level of protection that you need to keep the network stable. So first is abstracting the project plan up to a roadmap level where the network is stable. Second is placement of buffers. With these two conditions, your project plan at the roadmap level and the critical path at the roadmap level and the controlling paths, they will remain fairly stable. Right? So I'll give you another example. So we did a project with a wind turbine company. And so this is early stages of product development where there's just lots of changes that are happening. And this was about an 11-month project, and not even once was the project plan changed for those 11 months, right? Where you are doing a lot of system design, you're coming up with a lot of technical problems, and you can keep doing all that, but your project plan remained stable and did not change. Right, so combination of this data model and smart buffer placement will give you a stable network. Now the question is, how do you now still keep the project plan current, which is where the buffer monitoring comes in, which is as you make the real-time updates at this level down here, so you're making those real-time updates. So in construction industry, there will be daily progress reports. In engineering systems, you have, as engineers are marking off their list and completing their drawings, so they are recording it on a daily basis, what they're finishing. Or you could have your supply chain management systems, which are telling you what is happening with the material supplied, are there vendor delays, etc. As those changes happen, you need to do two things, which is very simple. You need to translate the impact of those changes to the delivery roadmap. And the second thing you need to do is you need to figure out, as those changes have happened and these tasks are taking longer or shorter, what is happening to the buffers, right? So it's fairly simple, right? So now the beauty of this is the process can be entirely automated. You do not need project planners on a daily basis going and mucking around with project plans. And normally what happens is the moment you have a lot of people messing up with the project plan, typically what we have seen in projects is that delays are happening, but the due date does not move. So what is happening is project planners are trying to keep the due date constant by changing the project plan, manipulating the project plan to show that the project is going to be on time. But of course, they are giving you unreliable information. And that is why what you experience in large projects is, let's say a 12-month project, for the first 8-9 months, the project is going to be on time. And suddenly in month 10, you find that project is 3 months behind. So how can it be? Because what is happening is the moment people start manipulating the project plans, they want to give a rosy picture to the management. They want to think that we can control all these changes, and despite all these changes, the project will still be on time. And so if you can automate this entire process where you create a project plan once and these execution details are changing, whoever is changing them, and that is automatically getting rolled up in real time in terms of management information, which is management is getting their alerts, and frontline people are getting their schedules. If you can eliminate this manual work, suddenly your reliability of information, there's another factor that comes into play, which is subjectivity is gone, and now it is all objective. Right? And this is really what we are saying. We said that this was kind of an impossible situation, but with this smart project model and buffers and buffer management, suddenly you can satisfy both sides. So you change your execution details, automatically you monitor the buffer impact, and your project network stays stable because your roadmap is not changing, and your smart buffer is stopping the critical path from shifting randomly. Right? So this is really what you end up with is like a Google map for projects. At any time, in real time, you can log into a project and you can see whether whatever the predicted date is, where are the bottlenecks, what are the alternative paths that you need to pursue to get to your destination on time. Right? And of course, you also get a single version of truth, which has been the nirvana in projects for a long time. And you can do it with much reduced planning and control effort. So this is one part of streamlining decision support. The second part I want to talk about is limited capacity. What is the optimal way to use limited capacity, and how does that translate into streamlining decision support? I think you already know this from experience, so I'm not going to belabor the logic here, but I'll still point it out. So just imagine that you have a project which has got all these teeny tiny tasks going on, right? And each task of a different color is done by a different set of resources. And in aggregate, since there is a preponderance of blue tasks here, this blue 5-week mega task is going to take 5 weeks with the resources you have. Similarly for the green tasks, and similarly for this pink magenta task. Right, so this picture is clear, right? So you have one project going on, which is this. Now, what you have is a situation where you might need to do 3 projects at a time. And for simplicity's sake, just for conveying the point, let's say that all these 3 projects are similar. They're exactly the same. It's just that the resources you have are the same as you had for one project, but now you need to do 3 projects. So you need to take these resources and find out what is the optimal way to use these resources across projects, right? And what is the due date going to be? So there are 2 modes of managing capacity. And I'll just point out both the modes: maximize resource utilization versus focus and finish. And now let me point out what is the difference. So maximize resource utilization, what it means is I've got 3 tasks, 3 blue tasks, mega tasks of 5 weeks each to do. If I do them one task at a time, then the total time it will take is 15 weeks. But in that process, my resources are going to be idle. My resources are not going to be all busy all the time. So I might see some downtime for blue resources, some downtime for the green resources, some downtime for the magenta resources. And what I say is that instead of suffering downtime, I'm going to maximize resource utilization. And by doing that, I can get those 3 5-week mega tasks done in 12 weeks instead of 15 weeks. Right? Same thing for the next phase, which is instead of 6 times 3, which is 18 weeks, and instead of 4 times 3, which is 12 weeks, I can get them instead of 18 in 15, instead of 12 in 8 weeks. So it looks good, right? It actually looks good. I have kept my resources busy, and this is the best I can get from limited use of capacity. Compare that to a different mode, which is we say, you know what? We don't mind resources being idle, but we're going to focus and finish our resources before they move between projects. And again, this is a very simplified picture. In the real world, you will have more than one project, more than enough resources for more than one project at a time, etc., etc. But even in this picture, Now what you see is, in the first case, to do 3 projects, it took me 12 plus 15, 27 plus 8, 35 weeks. In the second case, it took me 5 plus 6, 11 plus 6, 17, 23, 27, 27 weeks. So instead of 35 weeks, I got 3 projects done in 27 weeks. Right? So this is the part that gets missed out because people just don't know, so there's, in today's world, supervisors, frontline supervisors, all they can do is they can try to keep their resources busy. They really don't know what is going to happen downstream in the project. And when they do that, what happens is they get their work done efficiently, but they delay the start of downstream phases or downstream tasks. As a result, projects end up taking longer. Right? So in the same amount of time, we could have actually finished 4 projects instead of 3 in 35 weeks. Right? So this is, a lot of you already know this from experience, right? So whenever a project needs to get done, you focus your resources and your projects get done, right? And this is the logic behind it. Now, the point here is that the resources are not, resources and tasks that you're trying to optimize are not these, one person here, one person there, one small task here, one small task there. What you're really trying to figure out is, what is this focus and finish cycle times for each phase? And based on that, where the constraint is. In this case, the constraint happened to be the green set of resources. And that tells you, that gives you a very simple picture in a multi-project environment for what your capacity is. Right? You don't need to go and resource level load and balance every resource, every activity, and try to keep every resource busy. You just find out what is your constraint capacity, and based on the capacity of the constraint, you can figure out how many projects you can do at a time, and that is your capacity management system. The beauty of this is that a new project comes in. I don't need to go and create a very detailed project plan to predict a due date or to figure out when to put this project into the pipeline. I can deal with a much higher level of a project plan because I am focusing on the constraint and I'm doing focus and finish. Right? And what you get really is a GPS for your portfolio. Right? So imagine in Google Maps is not only telling you what turns to make, but it's also looking at all the traffic and is guiding all the drivers to say when is the right time for them to leave from their home towards the office or from the office to go back home, and is synchronizing all those decisions so that there is no jam even created on the roads. Right? So that is the potential if you can manage capacity in this way. Right? This is not possible in this scenario. In this scenario, there's always going to be, resources are always going to be busy. You will always have a jam. And you will always have a situation where you have less resources and more people shouting for those resources. Right? So this is the optimizing capacity part of the projects. So the point I will make again is that to get predictability and control, you need a stable roadmap, which comes from changing your data model and having buffers. The other side is keeping the information current. So again, that comes from being able to change those execution details automatically, roll them up, and analyze the impact on buffers automatically. For the capacity side, you need to figure out what is the model of your capacity. And this model of the capacity is not at these teeny tiny tasks, it's at a higher level. And the model of the capacity is very simple. How many projects can you do on the constraint at a given time? So given all this, what information do you really need as an executive? Not as a frontline manager, but as an executive. Right? So the information is actually pretty simple. These are the 4 areas you need to monitor. And by scope, what I mean is in case you're managing projects to a cash flow, so the scope could be a substitute for cash flow. But let me just go through each one of those. And right, so the workload All you need to know is in a multi-project portfolio is, are we overloaded or not? And the only information you need is what was our planned number of projects at any given time versus what is the actual number of projects we are operating with. And this is the simple information you need. If you had planned that you should be doing 4 projects in your systems integration phase at a time, but you have an actual WIP of 5, you know your entire organization is overloaded. You do not need more information than that. Or if you thought that you could operate with 4 projects, but in reality you have only 3 projects, that means you have room for pulling one more project in. Schedule is again becomes very simple. Now I don't need to monitor at what rate my concrete pouring is going on, at what rate my bricklaying is going on. That is not what a senior executive should be concerned with. And those are execution details. All the senior executive needs to know, if you have a stable roadmap, is what is my projected delay in the project? Is there a projected delay? My project was supposed to finish on 5th of January. Is there a projected delay? And this projected delay can be in terms of days or percentage of cycle time. Project was 10 months long, is going to be 2% late or 5% late, or it can be percentage of your buffer, right? Whatever suits you, you can use that metric. Scope, right? So the simplest measurement here is what is the percentage of scope in red. So I will illustrate it with the cash flow example. So let's say you are doing 5 projects, and each project has a different amount of cash flow associated with it. All you need to know now is what percentage of your cash flow is in red, which directly comes from the projection of delays at the project level. And so that's all you need to know. And then you can easily drill down which scope is red, and then you can figure out what corrective actions to take. And from a resource manager's perspective, so not from a senior delivery executive, but from a silo resource manager perspective, they just need to know what percentage of their workload is red. Right? So when I'm doing the projects and I'm monitoring my controlling path, all I need to know is how much of my workforce is required on the controlling paths that are really in danger of jeopardizing the due dates versus how much of it is working on the green workload. Right? So with these 4 simple metrics, suddenly at the top, you have very succinct information instead of this very busy cockpit with thousands of dials and graphs. All you need to know is these 4 metrics, and from there you can drill down to actions that you need to take. And with that, I'm going to end my presentation part of it and open it up for questions. So someone will need to read the questions to me, Saurav.
Yeah. Any questions from anyone? You can raise your hands, or you can simply type in the Q&A or the chat window.
And by the way, the next webinar is going to be conducted by Saurav, where he will actually talk about how to build these capacity models and the project roadmaps, using some real life examples from many different types of projects. Okay, I see one question.
So there's one question. What approach you follow for multi-project environment where several projects are competing for the same set of resources?
Yes. So the question is, so let's go back to multi-project. And so you have this situation, right? You have multiple projects competing for the same resources. So one approach, normally organizations are operating in this mode where they find that every project is taking too long and we can do only in 35 weeks, only 3 projects, right? So the first step is to change your mode of managing capacity so you can actually do 4 projects in a given time frame instead of 3. Right? So if multiple projects are competing for the same resources, a different way of stating the problem is that you cannot do enough projects. The first step is to try to do more projects with the same resources. So this is what you do. By moving to focus and finish, you can do more projects with the same resources. Now, if you find that, hey, we can do 4 projects, but really there is a demand for 5 projects. This is where management decisions come. So management can easily decide out of the 5 projects, which project cannot be done. Right? So you can do all kinds of analysis on that in terms of which one is going to give you more cash flow, which one is going to give you more market share, whatever your business objectives are. So,
Yeah.
next one.
Ayan has raised his hand. Mohsin, can you allow him to talk?
Hello, Ian. Hello, Ian.
Yeah, the mic is on mute.
There we are. Am I audible, Sanjeev?
Hi, Ian.
Hi, thank you. Sanjeev, what role do you see for managing the flow of more detailed work, incremental work? So whilst teams might be finishing at the project level, incremental bits of work like one of 100 data sheets. Now I'm making the assumption that you don't, that blue work flowing through, and what sort of signals help one task flowing from one to the other, more like a factory with repetitious work.
This is what happens here, right? So that project, so the more that I showed you for multi-project is a level up above this. Below that, you have a delivery roadmap for the project, and below that, you have the execution details. Right, so this is where the detailed work gets managed.
Yeah, I'm thinking more of the flow of individual work packages. So you might focus and finish a specialist team on everything they need to do, but if they have 500 ring beams, are you saying design all the ring beams before the first ring beam is started to be installed?
I'm not saying that at all. Your delivery roadmap will decide how many ring beams get done here and how many ring beams get done here. Right? Then it is just a daily detail.
Yeah. Okay. I was just wondering whether you saw a role for what some environments call project production planning, where they implement.
It's very common, Ian. So if I look at a typical construction projects, right? So just think of you're building something and you're laying piles, right? So you're building some infrastructure and you're laying piles. So this is like a production line. Your crew goes for 3-4 months and they're just operating a production line. That production line is operating at this level. Right? And right, so on a daily basis, and this task is an encapsulation of that project production line. Same thing happens in engineering. When you're designing a tanker aircraft, for example, you've got hundreds of thousands of drawings where people are just detailing out each component. Right? So there is an engineering team that is operating like a production line.
Yeah.
That production line details is here. This is an abstraction of that production line at a 2-3 month task level.
Yeah, I was thinking a little bit between the focus and finish tasks. May there be, for example, a flexibility buffer of completed designs for the piling gang on site to pick up and work for, so you make sure they're not interrupted because of upstream engineering activity.
Right. So I think we can take it offline. I'm not sure.
Yeah, will do.
Yeah.
Brilliant. Thanks, Sanjeev.
Yeah.
Okay, so there are a couple of questions on how do you deal with iterations
in
product development or agile project management?
Great question. So I am going to ask Mike to jump in. Mike Hamlin, he's a president of our field operations in the US. So iterations are very common in product development in the early phases, right? And I'll just give you a leading thought and Michael can chime in with more details. Can you open up the mic to Michael, first of all?
Yeah, I'm here, Sanjeev.
So the trick is that all the iterations are within these tasks. And the way you build a stable roadmap is that at this level, there's no iteration, there's no going back and forth, right? So you define these tasks. So, when the wind turbine example that I picked up, so they kind of define it as a room. They said, imagine a group of engineers getting inside a room for 2 months and whatever iterations they have to do, etc., go on here at this level. And at this level, the project roadmap stays stable. So Michael, but you have more hands-on experience, so you can explain it better.
Yeah, thanks, Sanjeev. I think you did a great kind of introduction there. I've seen two ways of doing iterations. The most typical is what Sanjeev's talking about, where the iterations are typically at the detailed execution level. So maybe I do some design work, then I'm going to pitch it over for some analysis. Maybe that's structural analysis. Maybe that is a test that I'm running, computer simulation test that I'm running, something like this. And I may do that 2, 3, 4 times, and historically people have a pretty good idea of how many times they're going to do that. So at the detailed level, we'll actually capture that iteration that we're going to do it. Now, maybe we planned for 3 times and it actually takes 4 times. This is where the buffer comes in. The second type, going back to Sanjeev talking about the wind turbine, but actually this was working with large gas turbines. We ran into a situation where the iterations were so large that actually we created iterations at the tier 1 level that Sanjeev's talking about. So here, where an iteration might take 2 or 3 months to complete all the design work that has to happen and testing before you can go to the next one, we actually rolled it up to the higher level. So we had iteration 1, iteration 2, iteration 3, and so on. Again, if we've miscounted on the iterations, typically the buffer, you're talking about projects that might be, 2 years long.
So you build that higher level iterations into the project delivery roadmap itself. So first set of tasks, iteration 1, second set of tasks is iteration 2, and so on.
We've done that once, right? That was with gas turbine, where they were very, very large iterations. Typically, it's more down at the execution level, where I may have, a whole iteration may only last a week or 2.
Got it. Like in testing, for example, software testing or systems testing. Yeah.
Software testing, or I think, and also in mechanical design, where I often do a mechanical design and then I do a structural analysis and go back and say, okay, I've got a weak point here. I need to change my design a little bit, like we did with aircraft. Designing the new aircraft fuselage, right? We would do some iterations where they do some design work, kick it over for structural analysis, and go back and do some more refining on the design to cut weight or build strength and things like that.
Very good. Thank you. Thank you. And if you have iterations that are really much more unpredictable than that, like in pharmaceutical product development, then you just have a different project plan for phase 1 and phase 2 and phase 3. And you don't even build a project plan for phase 2 until phase 1 is done. Okay, Saurav, next. Hi, Saurav.
Yeah, can you hear me now? The next question is, how do you set up the roles and responsibilities clear to avoid project management resources becoming the cure for all gap fillers?
Okay, can you open it up to Karthik? I need Karthik to explain this question.
Yeah. Mohsin, can you open up Karthik's mic?
Yeah, it's done.
Hi, Sanjeev.
Hi, Karthik.
A very informative session, first of all. Thanks a lot for this insightful session. So I basically am an executive vice president in a leading pharmaceutical giant. And what happens several times is, the roles and responsibilities, RASI matrix stays very much in the papers. But in practice, what happens is whenever there is a gap in the system or gap in the processes, it becomes like the project manager's responsibility to ensure that those are filled in. So how do we avoid this situation so that the scope creep of the project managers doesn't get into a limbo, and then the situation doesn't get into a mess?
Great question. So this is, by the way, a common problem in all project organizations, where no matter what the organizational hierarchy is, it always splits into two levels. There's people who do the work, and then there's people who kind of try to solve all problems and manage all the problems, right? So I will provide the lead in, and I will again ask Michael Hamlin to jump in with more detailed explanations. So at least what I have seen is, once you define your project plans this way, which is there's a delivery roadmap and there are execution details, this automatically starts to define your hierarchy of management on both the project side and on the resource side. Because what will happen is, you will have typically some managers responsible for these tasks and some managers, different set of managers responsible for these tasks. So any problems they cannot solve here falls into here. Above this, it goes to a project manager on the project management side. What happens also is, when you define your task this way, your resource groups also start getting defined. So instead of resources being these individual resources or individual skill sets, you define your resources as a set of resources where you have some blue and some green resources. And so you define your resources at a crew level, right? So again, that starts to, and typically in that crew, there will be one person who will be a resource expert kind of a person, right? So who can solve resource management problems or technical problems, right? So once this roadmap is built well, what at least I have seen is that trying to find here. What I have seen is that this also captures your organizational structure at some level and roles and responsibilities. And if roles and responsibilities have not been defined well before, forces you to define them when you do it this way. Michael, you want to jump in?
Yeah, I'm not sure what else to add, Sanjeev. I think you answered the question very well. I think, what we've seen in implementing this is that, it's, how do I want to say, it's really taken that resource and that roles and responsibilities kind of to at the tier 1 level. It's really more of a lead, or not a project manager, but more of an organizational team. It's a team lead that kind of oversees that, and the updating, or there's like a weekly meeting around that detail, that detailed tier 1 level. So I'm not sure what else to add to what you said. I think you answered it very well.
Okay, Karthik, I hope we answered your question, but if we did not, absolutely just feel free to engage.
No, Sanjeev, I think you gave me an insight which was very good. And I think we could build on it to a large extent to see how to get this done.
Okay.
Thank you very much for sharing the experience.
Yes.
The next question is this, or how is it different from the critical chain concept?
Very good. So critical chain. So obviously when we started building our processes and software, it was started with critical chain idea, right? But critical chain is kind of insufficient in the sense that if I have humongous networks, my critical chain is changing all the time, right? So in a 100,000 task network, my critical chain is changing, my task priorities are changing all the time, and it just doesn't work, right? In fact, that is kind of what led us to this innovation in the data model, both from the project data model and the capacity data model side. So the way I would say it is, for those of you who are familiar with critical chain, the idea of buffers and buffer placement comes from critical chain. the idea of having a different capacity model and a different project model, that is new thing that we have established on top. And we kind of, our customers who come from critical chain background talk about it as critical chain 2.0. Saurabh, next.
Okay. The next question is, as you are suggesting focus and finish approach to complete the projects, what are the criteria one should take into account to prioritize different projects?
Great question, right? So the criteria, I am not going to get into it because I am not that well versed with all kinds of business environments, and but there are many factors that go into it, right? There's risk aspect of the projects. There is what objectives you're trying to achieve, whether it's market share or cash flow or profitability, right? So all those are business objectives that people who have the context can decide best. I think where the only insight we are providing is that once you understand what these competing projects are, right? Now, with this picture, management can use their knowledge of what, if, for example, you find that delaying this project will actually cost you market share. So do this project first and do this project second, right? In this scenario, you can never decide because in this case, none of the business objectives is being met. Over here, once you lay down your pipeline like this, then you can find out which business objective is not being met and what one or two projects to move around to better meet your business objectives. Saurabh, next.
Can we have some examples of feeding delay so that the critical path is never changed?
Okay, I will rely on you, Saurabh, or Michael, you to give more frontline experience.
Understand the question, feeding delays?
I think the delays on the non-critical paths.
So what are the real examples, Michael? Instead of just a project
from my experience, there are lot of cases where, especially with equipment delivery, which you assume that are going to arrive on time and are not my major risk to the projects. Those are usually on the feeding paths or the non-critical paths, and later on vendor delays suddenly make them critical. So these are, I think typical examples would lie with them.
Karthik will have a good example for pharmaceutical industry. In the pharmaceutical industry, typically the clinical trials and approvals of regulatory processes is going to be your critical chain, critical path tasks. Everything else is on the feeding paths, whether it is setting up of manufacturing or the commercialization phase, etc. Right. So over there again, you want to not jeopardize your critical path. So you have these delays that happen all around, but your main critical path of regulatory approvals, etc., that clinical trials, regulatory approvals, that stays stable. Okay, next question.
Okay, the next question is, how do you manage uncertainties originating out of changes made by the customer?
Very good. So let's go back to the data model here. Right. So when those changes are being made by the customer, those changes could be affecting details here, or it could be affecting the network here. Right. So it's just like iterations that Michael talked about. So a lot of time those day-to-day changes, detailed changes get absorbed here. And the only thing that impacts the delivery roadmap is expansion of the durations of the task, which gets absorbed in the buffers. But sometimes you can have changes at this level also. If you know changes are already going to happen here, just like Michael said in the gas turbine case, where you actually planned those dummy iterations here, right? So some major change will happen, so you will have some tasks here for those expected changes in the scope. But most of the times, the scope changes get accommodated at this level. right? So let's take, I'll take a very trivial example because these are not real projects, software development projects. Right? So scope changes is all about, I want the feature to be behaving this way. I want my button to be here. I want my query to be run a certain way. Right? So those are all the detailed changes that get absorbed here. And at this level, you have only functionality that you're talking about. Next question.
How do you handle a situation where management gives a target of 24 months while the actual duration as per plan is 30 months?
Very good. So first of all, what I would say is if the actual target is 24, so the lead time is not determined by your internal process. The lead time is determined by the customer. This is just whether it's in manufacturing or supply chains or projects. The person who determines the lead time is the customer, right? So the question that arises is 30 months really your optimal plan? So I think you'll need to work with my team on the front line, Saurav, etc. What we normally find is that when you are operating in this mode, if you're operating in this mode, you think your lead time is 35 weeks, but actually you can get the project done in 15 weeks. Or if your project is going to sit in a queue, your project can be done in 21 weeks. Right? So the first thing I would examine is this the mode you are operating in? And if this is the mode you are operating in, figure out a way to change to this mode. So I'll pick up the shipyard example again. So these steel plates were held up for about 6 or 7 months. And yet we finished the project with 1 month delay. What did we do? We looked at the remainder of the project and we found that the rest of the project was planned more like this. So we moved into this mode, the rest of the project plan, and we were able to still finish the project only with 1 month delay. Okay.
Okay.
Next
There's
question.
one final question. I think it's again linked to critical chain. Should we take the task times as some predefined probability, like 50% probability, etc., or how should we decide the task time?
This is a question that is beyond my ken, beyond my range of knowledge, because I don't know how to define probabilities for tasks. Right? So this is not statistics where we have done thousands of data points around a single activity. So I don't even know what the distribution curve is for project tasks. So 50%, 90%, etc. I think these are all just very ivory tower concepts that don't apply in the real world in projects. Right? So the only thing you do is you build your project network and at this level and you say, you know what, we know there's a lot of details, but guys, realistically, how long will it take to do the intake well construction? Right? And you come up with your best guess and you live with it, because you really don't know whether it will take longer or shorter. You will figure it out when you get into execution. And they're just, again, there are so many, the challenge in projects is not that delays happen. And the challenge is also not that you have umpteen methods to recover the delays. The challenge in projects is applying those resources at the right points so that you can recover the delay the most. If your critical path is changing all the time, then you can never recover from the delays, no matter what probability distributions and distribution points you use in estimating your tasks. The challenge in projects is knowing where to focus. And if you focus your expediting capacity, resources, etc., in the right place, and that critical path or the controlling path will not change, you will achieve a better result. I mean, there is this project, the project world is littered with these. I don't know if you guys remember in Israel, they had this bombs flying in and they built this iron dome in a record 3 months. The COVID vaccine, normally how long does it take to do this, COVID vaccine development. Look at how fast it got done. Every project has a lot of wasted time in it. Okay, next question.
I think that brings us to the end of all the questions.
Okay. Thank you very much for devoted almost an hour and 15 minutes to this. And we will welcome any questions. You can send them to me or to Saurav or to Michael, and we will answer those questions. And as I said, there will be a follow-on webinar. Saurav and his team will send out details for that. I think those are going to be customized webinars. You want to talk about that, Saurav?
Yeah, those will be customized webinars. Those who are would be interested in understanding how it can be applied to their environment, we will do one-on-one sessions with them to show them how to apply the concepts that Sanjeev has explained here in very specific project environments, and show how all these concepts that were explained, how they will apply.
Hey, Saurav, you might want to share with them Michael's webinar that he did before the customized webinar, in case people are interested.
Okay. So there are some requests for also sharing this presentation, and I will share Michael's webinar also with the attendees.
Okay. Thank you, everyone, again.
Thanks a lot.
And thanks, Saurav, for organizing it. Thanks, Mohsin. Thanks, Michael.
Listen to you.
Thank you.
Take care.